Greetings, my fellow coded enthusiasts. Today, I want to share with you everything there is to know about programming language. Now, I know what you're thinking. Everything. That's a bit ambitious, isn't it? But fear not, my friends, for I have spent years researching and acquiring knowledge on this subject. Let's start with the basics, shall we? A program is a set of instructions that tell a computer what to do. It's like a recipe, but instead of cooking food, you're cooking up a software application. But here's the catch. Computers don't understand human language like English or Spanish. They only understand something called machine language, which is a series of zeros and ones. So to create a program that a computer can understand, we need to use programming languages. These are like special languages that computers can understand. Programming languages come in different levels, from low-level to high-level. Low-level languages, like assembly language, are really close to machine language and are used to write programs that interact directly with the hardware of the computer. High-level languages, like Python, are further from machine language and are easier for humans to read and write. They're used to write programs that are more abstract and complex. When we write a program in a programming language, we can't just give the computer plain text. We need to translate our code into machine language. This is where a compiler, interpreter, or assembler comes in. A compiler is a program that takes the source code written in a high-level programming language and translates it into machine code that can be directly executed by a computer's processor. The compilation process involves multiple stages. First stage include lexical analysis. This stage breaks the source code into tokens, which are the basic building blocks of the programming language. Second stage include parsing. The parser reads the stream of tokens and checks whether they form valid expressions or statements according to the grammar of the programming language. It then produces an abstract syntax tree, AST, that represents the structure of the program. Third stage includes semantic analysis. The semantic analyzer checks whether the program is semantically valid, that is, it checks for issues that cannot be caught by the parser. Fourth stage is code optimization. The code optimizer analyzes the AST and generates an optimized version of the code that is more efficient in terms of memory usage or execution time. And fifth stage include code generation, where the code generator takes the optimized AST and generates machine code or assembly code that can be executed by the target processor. Some of the language that use compiler are C++ and Swift. An interpreter is a program that reads and executes code line by line. Unlike a compiler, which translates the entire program into machine code before execution, it interprets each line of code and executes it immediately. This makes the execution slower compared to compiled code, but it also allows for greater flexibility and dynamic behavior. The interpreter process involves multiple stages, including tokenization, parsing, interpretation, execution. This process is more straightforward than the compilation process, as it does not involve code optimization and code generation. Some of the language that use interpreter are Python and JavaScript. An assembler is a program that translates assembly language into machine code. Assembly language is a low-level programming language that uses mnemonics and symbols to represent individual CPU instructions. This is one example code using these mnemonics and symbols. Note that assembly language varies depending on the specific processor and architecture being used. The above examples is just a general illustration. Now the generated machine code gets stored in an object file, which is then linked by a linker to create an executable file that can be run on the target machine. Now tell me, have you ever wondered how different programming paradigms can change the way we think about and approach problem solving in code? Let's dive into two popular paradigms, procedural programming and object-oriented programming, and see how they stack up against each other. First up, we have procedural programming, also called POP. This is like following a recipe step by step. You know, like when you're cooking and you have to follow a recipe to make a delicious meal. In POP, you're writing procedures or functions that perform specific tasks, just like following the steps of a recipe. And just like how you need the right ingredients to make a great dish, you need the right code to make your program work. Now onto object-oriented programming, also called OOP. This is like building a set of Lego blocks that can interact with each other. Imagine you have a bunch of Lego blocks, each with their own unique shape and color. In OOP, you're creating objects, which are instances of classes that have attributes and methods. These objects are like the Lego blocks. They have their own unique properties and abilities. And just like how you can connect Lego blocks together to build something awesome, you can use objects to create complex and interactive programs. So, if you're a procedural programmer, you're like a chef following a recipe to create a delicious meal. And if you're an object-oriented programmer, you're like a Lego master building a towering structure out of tiny blocks. Either way, you're creating something amazing with your programming skills. And let's not forget about the history of programming language. Did you know that the first programming language was created in the early 1800s? It was used to control mechanical looms in the textile industry and was called Jacquard's loom. The language was designed to allow looms to weave intricate patterns, and it used punch cards to store the instructions. Fast forward to the mid-1900s, and we see the development of the first electronic computers. This led to the creation of the first high-level programming languages like Fortran and COBOL. These languages were designed to make programming easier and more accessible to a wider range of people. In the 1970s and 1980s, we saw the development of more powerful and flexible programming languages like C and C++. These languages were used to write operating systems and software that required low-level access to computer hardware. Now, in the present day, programming languages have come a long way since Jacquard's loom. We have languages that can create websites, mobile apps, video games, and even artificial intelligence. Some popular programming languages include Python, JavaScript, Java, and Swift. In conclusion, programming languages have a rich and fascinating history that spans centuries, and they continue to evolve and shape the world around us. From Jacquard's loom to artificial intelligence and beyond, programming languages have become an integral part of our daily lives. But this is just the tip of the iceberg. There are so many programming languages out there, each with their own unique features and capabilities. If you're interested in learning more, be sure to subscribe to our channel and watch our other videos about different programming languages. And let's not forget about the future of programming languages. Who knows what we'll be coding in 10, 20, or even 50 years from now? Maybe we'll be coding in our sleep, or maybe we'll have robots do it for us. The possibilities are endless, and that's what makes programming languages so exciting. So, if you're passionate about coding or curious about the world of programming, make sure to subscribe to our channel and stay tuned for more exciting content. Thanks for watching and happy coding.